So our next example is another four-oriented trajectory. So this time we're going to detail the motion of a ball as we throw it up in the air with some speed. So if we have thrown upward with an initial velocity of 20 meters per second, we can describe its motion with the standard kinematic equations, and we can answer these questions that are posed here. How long is the ball in the air? How high does it go? And then specifically, let's look and see how long it takes to get a specific point along its trajectory. So this is a much more specific question. So let's go through these one at a time. So first of all, we can ask, how long is the ball in the air? And so from the last problem that we did, we looked to see how long it took the ball to get halfway through its motion and then come back down again, and that was the total time. So we can do that again, just to make sure that we remember how to do that. And so we know that the final velocity is equal to the initial velocity that we threw it with, except that we changed the sign. So we know that V final is equal to minus V initial. We spent 3 times proving that on the previous problem. So we know that we can figure out the total time because we know that we can say V final is equal to minus V initial is equal to our description of this motion in the kinematic equations, which was V initial minus G times the total time it takes to fly. And so again, we're setting these equations up. We've defined the vertical direction, the upward vertical direction, to be positive. So again, my acceleration due to gravity over here is negative. Okay, so using this information about what a projectile looks like, then we can solve for the time it takes to fly the entire distance. And so if we solve this out, we see that minus 2v initial is equal to minus g times the total time it takes for the projectile to fly. And so the total time then, t total, is equal to 2 times the initial velocity divided by the acceleration due to gravity. This is an expression that we also derived in the previous time when we were working through similar equations. And so if I take this and I plug in 20 meters per second for the initial speed and 9.8 for g, then we get that the total time is equal to 4.08 seconds. So then there's another way to do this. We could say that the projectile starts and ends at a height y equals 0, and we can use the distance equation instead of the velocity equation. So we could also say that y final is equal to y initial plus v initial times time. And again, since we've defined the positive direction to be up, this is going to be minus 1/2 gt total squared. That's what we're going to do. And so this will also be a t total here. And so we can say that the initial and final positions are the same, since I throw the ball up from the ground and it comes back down to the ground. So y final is equal to y initial, and so these are going to cancel out. And so that leaves me with v initial times the total time is minus 1/2 g times t total squared is equal to 0. And so I can move one of those onto the other side. So I have v initial times the total time is equal to 1/2 g times the total time squared. One factor of time cancels out of both sides, and this tells me that the total time is equal to 2v initial divided by g, which is the same thing that we got over here using a different equation. So that's good. That at least tells us that we're doing something that makes sense. The third way to do this is to find half the time it takes to get to the top, and then we know that that's half the time, and we could multiply by 2. Since that's very similar to the top one here, I'm not going to write that out again, but that's another way to think about this motion.